Hello guys, today I'm going to explain you how can we solve this problem Knapsack 1 from educational DP contest at Atcoder. So this is problem D, and the problem statement is very well known. It's about like the problem statement says that there are n items which are numbered from 1 to n, and each of these item has a weight assigned to it and also some value. So our goal is to and also we are given a knapsack of some w capacity. So what we need to do is we want to pick certain items out of these n items such that the sum of all the weights of the items that we pick must be less than or equals to this knapsack capacity, and so we should choose the ones which will give us the maximum value. So the overall profit should be maximum, also considering that the total sum of weights is less than or equal to the capacity of the knapsack. So this is very well known problem, and what I'm going to show you how can we also solve this recursively, and keeping the rhythm the same way that we have solved the problem A, B and C in the using the memoization technique. So let's see how can we solve this one. So let's first talk about certain approach that one who is not very familiar with this problem can try to give a try. So one of the approach could be to sort these items that we have by their weights. Alright, and then what he will try to do is he will try to add up first some items such that the sum of their weights are less than W, and then they will calculate the sum of the values of those items. But that would not always work. The reason is that there can be certain W or certain item later here which is bigger than all of them and all of their sum combined, but less than the overall capacity. Let's say we had this W5, but its profit is also way bigger than compared to the sum of all of them. So we could just have chosen this one, and because once one can argue that why not this can also be included. But let's say if this was something which is very close to, let's say it will cover almost all of the W or even the W itself, so adding one more to with this one wouldn't be possible. So that's why our approach one we will try to get the some maximum ones and then add them here. But as you can see here, the one which we missed to add here can also give us the best result. So this approach wouldn't work. The other approach is that we will try to sort this one in descending order of the prices that we have. So one can argue is that what we can do is we can just sort this by the descending order of their profits, the values A1, A2, A3 and A4, and try to see if let's say we picked up the largest possible value and see if the weight is still below this, the remaining weight is still below the still greater than 0. So basically let's say A4 was the maximum here and we picked this one and we said that W minus W4 is still greater than 0. So we will try to check which is the next one. So we'll try to pick the best value for W3, and let's say W3 was the A3 was the best next value. So we see that maybe this is the case when W3 cannot be included into our knapsack, because W3 is greater than the remaining weight that we have here, that is W minus W4. So in that case we might there might be a scenario where W3, W2 and W1, each of them, the sum of all of these were still less than W, and their sum, the A1 plus A2 plus A3, is greater than A4. So in this way we can also say that this argument is also not valid one. So now that we have seen both of these approach might lead to a failure, let's see what can give us the best result and what should be our approach. So in all the problems that where we are given such similar questions whether we are given certain number of items to choose, we always have an option of either choosing it or not choosing it. So by saying that, what I mean is, in here as well we are given certain number of items in an array, and we want to pick some elements such that our maximum profit is we get the maximum profit, and some of all these weights are less than w. So we always can either pick one item or not pick. So to not pick, there is no rule that we need to follow, but to pick an item we need to keep in mind that the overall sum till now, the value of the weight, the sum of all the weights till now, and adding this particular item does not increases the overall weight. So with the things that we discussed till now, let's try to build our recurrence relation now. So now we shall talk about our state at any moment. So we have certain number of items, and we are always trying to either choose one item or not. So let's say we are at certain item I, and what else do we want to have? We said that we are all, the weight, overall weight that we have picked up is also a very important factor here. So we will keep another param, that is the weight till now that we have picked up. Is there anything else that will make any difference here? I guess no. So yeah, these are the two things that are going to make changes into our state transition, or I mean, these are the things that are going to affect the states. So what do I mean by changing the state or state transition? So at any moment we have two options. So the options are that we do not pick this ith item. That means we can just go to the next items, that will be I plus 1, and if we haven't picked up anything, that means we are not increasing the overall weight that we have picked up till now. So this should also remain same. Alright, so now here we have an option of choosing this one. So here we talked about the case when we don't want to choose the ith item, and here let's talk about the case when we want to choose the ith item to be included into our knapsack. So here we said that we are going to first compare the overall sum till now, that is this w, plus the w of the weight of this item. We will check if this is less than or equals to the overall sum, that the capital W that we have, overall capacity, then only we will try to include this. Otherwise we will just ignore this option. So what are we going to do now is I plus 1, and now that we have increased this W, so this should be changed to W plus W of I. Alright, so yeah, I hope this is clear. And then what are we going to do? We are going to recursively check for these two different options as well. So from here onwards we will try for I plus 1th item, and for that item as well we have an option of either choosing it or dropping it. And then here we have an option of when we went ahead with the option of choosing, then also we have certain W, which is which will be the overall weight till now, and then we will have an option of choosing the next item or not. And in the end, what are we going to do here? We are going to compare these two results, and also we said that we want to gain the maximum value that we can have. So in here we did not add anything, so we will not have any value added to our choice, and here we added one weight, so the value should be equals to the a of I. So what are we going to do? We are going to compare these two, and the maximum of these two will be our result. Now let's talk about what should be our initial state. The initial state is we are first going to decide on the 0th item, and till now we have 0 weight included into our knapsack. So we will start from this initial state, and we'll try to solve this problem recursively, and then we'll try to memoize it. So let's see how we can code this one. Alright, so I have already declared certain variables and array. So n is the number of items that we have, overall items, w is the overall capacity of the knapsack, w array, smaller w is the weight of each items out of these n items, and then the v is their corresponding value. I have taken this input, and now let's try to build our function. So our function is named as long, and we have id. And what else did we say we'll have is the overall weight till now that we have. And our base case should be that when we are at the end of the array, the overall item that we have, that means we don't have any items left, then in that case the gain would be 0. We cannot add anything, so we'll not add any weight le value. And on the other hand, if we are not on the end of the array, that means we have certain answer, so let's call that answer equals to the option. The first option that we had was that we can just ignore this item and we can go to the next item without adding any extra weight to the overall weight that we have till now. And now we will check if we are going to include this particular item into our knapsack. So in that case, we are going to just check if w of I is less than or equals to, or the sum of w plus yeah, I think we can change this to overall weight w, and this should also be changed to wt. So this wi plus wt is less than or equals to the overall w, the bigger capacity that we have. If this is true, then we are going to say the answer should be the maximum of the answer from here. That means the option of not choosing this. And when we choose this one, then we are again going to choose the next to decide upon the next element or not. And now the weight, the overall weight till now should be increased to wt plus w of I. But here we have added something, so we are going to gain something as well. So we will add this w of id, and this should also be w of id. Let me change this to w of id as well. Yeah, and this should be the maximum of all these, and the answer should be the maximum of both of these options. So let's now try to run, and yeah, as I said, our initial state should be, it should be we are on the 0th item. Until now we have added w overall 0 weight into our knapsack. Also, I need to define certain directives so that I can read the input from here itself. This should be if and if it is not an online judge, then read from my input file input.txt, and with read mode, and it should be coming from std in. Otherwise also I have to write it back to output.txt in the write mode using std out. All right, and this should be end of. So yeah, now let's try to run our code, and we should get 90. Yeah, that's correct. So as you can see that we have solved this recursively. So here we have an option of either choosing any item or not. So the complexity is exponential here, because for each item we have yeah, two ways, either 1 or 0, like we are choosing or not choosing. So overall options, the overall permutations, the total number of permutations, the possibilities that we'll have will be 2 to the power n. The n is the size of the array. So how can we optimize it? So if you look closely, what are we doing here is we are either choosing or not choosing. So at any moment we can have same weight at the same id at certain position. Why can that be possible? Is because let's say we have chosen first 3 items and we gained some weight, and we didn't choose fourth value, and we reached that to some weight, let's say 10, and we could have reached at the same 10 at the fourth value, fourth item, by choosing 2 and 3 only, or 1 and 3 only, or some other options before coming to 4. And that's why a recomputation is happening, is going to happen. And to avoid that, we are going to use memoization technique. And yeah, let's just try to first see what is our constraints that we have, and then based on that we are going to declare our dp table to memoize this. Alright, so to memoize, what do we need is we need to have some table where we can store all the IDs and the overall sum that we can get at until any moment. So if you look closely, the overall numbers of IDs or overall number of items is n, and the capacity can be as big as the w. So we are going to store what is the the constraints are here. So we are going to declare a DP table of 100 cross 10 raised to power 5. So the overall size of the array is 100 only, so we can just reduce this. I don't know why did I choose that. And then we can declare our DP table, which can be of this big, I mean overall items and the overall capacity that we can have, W and ID. And then let's try to initialize it with some value so that we can identify whether we have already seen this or not. So we can just insert -1 to every element in the DP table, and then we can say if this ID or this state is not already seen. By checking if it is not -1, then we can assume that we have already seen this state before, and we can just simply return the value calculated for this state. Otherwise we can just memoize it after once we have calculated the answer. So yeah, this is how the memoization works, and let's now try to run this code and see. So again we get 90, and now let's try to submit our code and see if it works. So yeah, let's try to submit it here, and you can just simply comment it out so that it doesn't bring any compilation error or wrong answers as we have seen in the past. Yeah, let's submit. It's waiting to be judged. It's running. Seems like, yeah, it's going to pass all the test cases, and yeah, we have seen and is all correct. So I hope I was able to explain this properly. Yeah, and if there is any doubt or any comment or any feedback from me, please leave it in the comment section below. And thanks for watching this video, guys. Please do subscribe to my channel if you haven't already.